Hey atoms, we all live under the same sky. But have you ever wondered why the sky is blue? So let us explore on that today. First, let us have a look at a prism. It's a wedge-shaped transparent glass. When a white light passes through one face of it, we see rainbow colors appearing on the other face of it. So all these colors belongs to visible region, which means human eyes are sensitive to all these colors and therefore we will be able to see it. But the light that we receive from our sun has various regions like radio wave region, microwave region, X-ray region besides this visible region. So we call all those regions as invisible regions because human eyes are not sensitive to all those regions and therefore it's basically invisible. But for the discussion that we are going to have today, we will just focus on this visible region. So let me just quickly write down two colors, blue and red. So of these two colors, blue has the shortest wavelength and red has the longest wavelength. So here I have introduced a new term called wavelength. So what exactly is a wavelength? Let me draw a wave. This is how we represent a wave. So the peaks that you see here are called crust, and the depressions that you see here are called trough. So the distance between two successive crusts or two successive trough is what we call a wavelength. So when I say that the blue color has the shortest wavelength, what I mean is the distance between these two crusts or these two trough is shorter for blue. And when I say that the red color has the longest wavelength, the distance between two crusts or trough is longer. So the wave for blue will be somewhat like this, and for red it will be like this. Yeah, so you can see the change in the distance between two successive crusts and troughs. So this is what we call a wavelength. So here I'm trying to connect this wave to a color. So are we saying that the colors are waves? The answer is yes. Colors are waves. Just like how light from a tube light travels as waves and reaches us, just like how the light from the sun travels as waves to reach us, the colors also travels as a wave to reach us. So coming back to our discussion on why the sky is blue. As we have already seen, the light that we receive from our sun has various regions like visible region, X-ray region, UV region and all. But human eyes are sensitive to only the visible region, so let's just focus on that visible region. So the visible region of light, which has various colors, will have to pass through the space and will have to pass through the Earth's atmosphere before reaching our eyes. But we know that the space basically has no particles, but our Earth's atmosphere has millions and millions of particles. So what these particles does is that it scatters the light rays which is falling on them. So the particles which is in the atmosphere will scatter the light rays which we are getting, which is coming from the sun. So we call this phenomena Rayleigh scattering. So according to this theory, all the light rays, all the colors which is falling on the particles will be scattered, which means we should be able to see various colors in the sky, but we are able to see just the blue color. Why is that? So to explain that, we need a formula. So according to Rayleigh scattering, scattering is inversely proportional to the fourth power of wavelength. So for blue color, blue color has the least wavelength. So the wavelength is small, which means the scattering is very large when compared to all the other colors. So the color which has the largest scattering, which is scattered the most, will be visible to us. So that's why the sky appears blue. I can give you an example for this. So imagine yourself as a small kid. So when a big ball like this approaches you and it hits you, you would be helpless and you will fall to the ground. But if you are a grown adult, then you will not fall that easily. You will be able to prevent yourself from falling. So now imagine this small kid as blue color and this ball as a particle. So when blue color comes in contact with a particle, it easily gets scattered. But when a particle comes in contact with the red color, it will not be scattered that easily. So this is basically what I explained here. Blue color, which has the shortest wavelength, will be scattered the most, and the light which is scattered the most is the color that we will be able to see. So that's the theory behind why the sky is blue. You might be wondering about the reddish sky which we see during the sunrise and the sunset. So let's analyze that as well. So when you go out to your terrace at 12 in the noon, then you will see that the sun is exactly overhead to you. So in that case, the distance between you and the sun will be small. But during sunrise and sunset, the sun will be at the horizon. When the sun is at the horizon, the distance between you and the sun will be large. So the blue color, which has the shortest wavelength, will be scattered the most, so it will get scattered here itself. Only the red color, which has the longest wavelength, will be able to pass through the space and it gets scattered here. So since the red color is scattered, near the Earth's atmosphere, I mean the lower layer of the Earth's atmosphere, we will be able to see red color only during those times when the sun is at the horizon, and sun will be at the horizon only during the sunrise and the sunset. So that's why the sky appears reddish during the sunrise and the sunset. So that's it. In this video, we have seen why the sky appears blue during normal times and why it appears red during sunrise and sunset. Hope you enjoyed this video. Thank you.